On problems like this, you have to solve for an x. It's inside the absolute value bars. You got to really consider what the absolute value actually means. So this whole thing's going to end up equaling 13 once you take the absolute value. What we need to understand is the absolute value of positive 13 is going to equal 13, but then also the absolute value of negative 13 will equal positive 13. Knowing this, 2x plus 5, which is in this absolute value, 2x plus 5 can equal positive 13 or negative 13, because either one of those, once you take the absolute value, will give you a positive 13. So long story short, your setup, you need 2x plus 5 to equal either positive 13 or negative 13 for the equation to work. So I'm just going to set up two different problems. I'll have 2x plus 5 equals positive 13. But then we'll go ahead and set up 2x plus 5 equals negative 13. Let me fix that negative 13. All right, so now I've just got two different two-step equations, and I can solve for x, and either one of these x values is going to work. So subtract 5 here and there. I have 2x is equal to 8. Once I divide by 2, then x will equal 4. And then on the other side, I subtract 5 from each side. I have 2x is equal to negative 18. When I divide by 2, x will equal negative 9. So, let me fix my 9. So, what's going to happen here, let's go ahead and plug these back into the original and make sure they work. So, if I have 2 times 4, and then I add 5 to that, take the absolute value, should equal 13. So 2 times 4 is 8. End up with 8 plus 5, which is going to be positive 13. Yeah, the absolute value of positive 13 is 13. And then the other way, I'm going to say, okay, well, 2 times negative 9, that's my absolute value bar. 2 times negative 9 plus 5 also has to come out to 13 if you take the absolute value. End up with negative 18 plus 5. And then I end up with absolute value negative 13 equals 13. Don't be confused thinking these are ones. These are absolute value bars. And that's true. So the absolute value of negative 13 makes a positive 13. That's how you would check those. But again, the main thing that you need to know is anytime you have to drop these absolute value bars, once everything else is off this side, because you might have had other stuff, once everything's off of this side except for what's in the absolute value, then you can drop those and set up two equations. And I'll give you another example of this. Now with this problem, we have a negative 5 or a subtract 5 on the same side as what we already have our absolute value stuff. So first thing we want to do is move that 5. We're going to add 5 to each side. And we'll just bring down our absolute value of x plus 8. And that's going to equal 7. Now once we get to that 7, now we're at the point to where if x plus 8 equals positive 7 or negative 7, that's going to make that true. So we want to set up two different problems. We're going to say x plus 8 equals 7, and then x plus 8 equals negative 7. Again, because as long as this total ends up set positive 7 or negative 7, we can take the absolute value of that negative or positive 7 and get a positive 7. So we can just do the math now. Subtract 8 on each side, and x will equal negative 1. And then we can subtract 8 on each side over here, and x will equal negative 15. That's all there is to it. There's nothing else you have to worry about. The main thing with these is when you get to this point to where you can't do anything else over here without getting rid of the absolute value stuff, that's when you set up to a problem or two different problems, and you use positive 7 and negative 7 because the whole thing's got to equal that positive 7. Now, let's just go ahead and say, just for argument's sake, let's say this was all took care of. We didn't have any of this. But let's say that we had absolute value of x plus a equals negative 7. Well, at this point, there's nothing that you can take the absolute value of that will give you a negative 7. This number always has to be positive. Whatever you're left with by itself on one side, on the opposite side of the absolute value, it has to be positive. In this case, you've got that to where it says negative. That's no solution because it's impossible. You can't take the absolute value of any number and have the resulting value be negative. Absolute value is always positive. This problem is probably one of the most involved problems you're going to have with absolute value. With this, you've got a lot going on. You've got the absolute value of 5x minus 5 that's been multiplied by 5, and then you take 2 and subtract all that to get the negative 73. We're just going to work our way back down to where this is by itself. So to do that, we first want to get rid of the 2. So we're going to subtract 2 on each side. That's going to leave negative 5 times the absolute value of 5x minus 5 is equal to negative 75. At this point, now we have a negative 5 times our complete absolute value of 5x minus 5. So to get rid of that, just like anything else, we got to divide it. So we're going to divide by negative 5 on each side. And I'm going to bring this down. 5x minus 5 in the absolute value. Negative 75 divided by negative 5 is a positive 15. And at this point now, we can set up our two problems. So we'll have 5x minus 5 equals positive 15, and then 5x minus 5 equals negative 15. I know my 5s are ugly, but you know what they are. I'm telling you what they are as I write them. So I'm going to add 5 over here to each side. I have 5x equals 20. And we know when we do that, we divide by 5 on each side, and x will equal 4. And then on the other side, we've got to add 5 on each side. We have 5x equals negative 10. When we divide by 5, x will equal negative 2. And I know I did that kind of quick, but that's basic two-step equations that I know you have seen a lot of.